Network engineers talk about automation all the time, but no one actually shows you what a real automation stack looks like from end to end. Today, I'm going to walk you through a full network automation lab I built in Docker. Cisco NSO managing 8 devices across 2 vendors, a ticketing system, monitoring dashboard, and an AI that can push configs with plain English. Everything you see is running right now on a single server in my home lab. Let's get to it. All right, let's get started. What we're working with here is Docker Compose with 9 containers running on a single home lab server. We have Grafana, NSO, Prometheus, and some other things we'll get into in a second. At the core is Cisco NSO, Network Service Orchestrator, the same tool Fortune 500 companies use, connected to 8 simulated network devices across 2 vendors, Cisco and Juniper. We do this curl command, and you can see that we have these devices right here. 2 border routers on Cisco iOS, 2 distribution routers on iOS XR, and 4 access switches on Juniper Junos. Multi-vendor on purpose because that's reality. NSO has a single source of truth for every device config in the network. Let me pull some real configs. Real interface configs, gigabit Ethernet 00 is the ISP uplink, 01 and 02 go to the distribution layer, all managed through one API. Different vendors, different config format, same API. NSO abstracts all the vendor differences away. You can see all these 8 devices are in sync. If you guys have any questions about any of this stuff or need me to slow down, we can put it in the comments. Every change starts with a ticket. I'm using Tiaga, open source, similar to Jira. Here's the project board for our fictional company, Apex Networks. Infrastructure ticket already done, real work in the backlog, VLAN provisioning, OSPF, BGP peering, compliance checks. Let's pick one up and actually do it. The request, deploy VLAN 200 for marketing department across all 4 switches manually. That's 4 SSH sessions, 4 config changes, 4 changes to make a typo. With NSO, watch this. No VLANs configured. As you see, we run this curl command, which is executing the Junos command, and now we've sent that VLAN to all 4 switches, 4 204s, done in seconds. And now we check the status, and we can see here that all 4 devices are still in sync, meaning that the configuration on those devices are the same as what's in NSO. VLAN 200 is now on the switch. We do this curl command, and we do the configuration, and as you can see, Junos VLAN, we're doing the name, marketing, description, marketing department, VLAN 200. That's the power of automation. 1 loop, 4 switches, verified, done. Ticket closed. Do we go for the full automation and have the script update the ticket? Security wants us to audit all 8 devices manually. That's 8 SSH sessions with NSO, 1 API call per device type. 8 devices, 3 vendors, all checked in under 10 seconds. That's what real network automation looks like. We run this next curl command, and we can see we have these gigabit Ethernets all configured, and we're going to do some magic on the border routers. Every interface should have a description. Now we know exactly who's compliant. Every network engineer's nightmare. You push a bad change in the middle of a traditional network, you're SSHing into each device trying to remember what you changed. With NSO, it's one command, watch. Oops, we just overwrote the ISP uplink descriptions on both routers in production. That label might be the only thing telling the NOC which circuit is which. Verify the damage. Yep, they got the wrong descriptions. Yep, both routers show the wrong descriptions. Time to fix it. And we run this command to get rollback history. We see that we have these 5 commits. We'll go ahead and initiate. NSO tracked every commit. Let's roll back the last one. Type the curl, and it is restored on both BDR routers 0 and 1. Verify the fix. Uplink to ISP1, ISP2. We now have all this automation in place, and you can see we're doing all this with curl commands. So we can write any Python, do all kinds of magic with this kind of automation, talking to the network. Back to normal, one API call, both routers recover simultaneously. That's not just automation, that's insurance. Everything feeds into Grafana through a custom Prometheus exporter that scrapes NSO every 30 seconds. We query the Prometheus metrics directly, curl this to the metrics, and you can see we get these stats. Prometheus collects these in a time series database. NSO status, device count, sync status per device, alarm count, commit queue size, all exposed as Prometheus metrics. Grafana turns these into dashboards. All right, so we set up this Grafana dashboard. You can see we have NSO status is up, managed devices are 8, 0 active alarms, 0 in the commit queue, and then we can see that our simulated NetSim devices are all in sync. Alarm history is none, device count over time if we add any more, and NSO uptime. Simple Grafana dashboard, but as you'll see in some of the upcoming videos and whatnot, we're using this as a way to see metrics and use automation because we have APIs and things like that with Grafana. So stay tuned. We got more coming. Okay, now this is where it gets interesting. I have Claude by Anthropic AI connected directly here in my terminal. I created an MCP server, and we can get into that later, but that allows us connectivity and how Claude knows how to communicate with NSO through the MCP server. So if I just type in human English, all devices in NSO, it's going to reference that in the MCP server, connect to it, and should give us a list of devices. I mean, you could obviously log into Cisco NSO, do a show device, and get the same thing, but here you go. We can see that we have some Junipers, some Ciscos, iOSs, iOS XRs, and they're all in an admin unlocked state. And so we could do something like show me the interfaces on BDR. Yep, well, this is doing its thing. I just want to say I have a link down below to primenetwork.me/docs. It shows you how to go through all this, set up this whole lab environment and all that thing. So here we are. It lists all the interfaces on that device in a nice little context here, you know, showing us the IPs, the network mask, the whole works. I mean, this is fantastic. But let me show you the real test. Are any of these devices out of sync? Because we need to sync the configuration of the device with NSO, that running config. And usually what we use NSO for is that we define services out of that running config. And as long as these configs are in sync, it knows what it needs to change. So we just do a basic command here. We're checking the sync. Everything is good except those couple other unsupported devices. I'll clear that up. We'll get that all fixed up and ready to go. So let's try something real, like configuring some network devices, but having AI try to figure it out for us. So if we say add VLAN 300 called engineering to ACC switch 0 with a dry run first, because what we want is to see if it can actually deploy the configuration that we want, and we want to see what the results are of what's going to actually change on the device without making any changes, you know, so we don't make a oops in production and break something. That gives us the ability to just compare the configurations. Some of you old Cisco folks know iOS. You make a change, shit breaks, not good. Then you guys got iOS XR and things got better. But me as a Juniper guy, I've had that for a very long time. So as you can see here, here's our dry run. We're going to make this change and it all looks good. So I could go ahead and commit that. It wants to know, sure, go ahead. And it should just make those changes. No big deal. But think of the power of this. Junior engineers not fully understand, but can use basic English, translate a ticket to production by just typing into a CLI prompt with AI, and it be able to take that, render it, extract it, and then deploy into the network. It's crazy. I just deployed a network config change by asking in plain English. No CLI syntax, no REST comp path, no Yang models, just words. This is not a gimmick. This is actual NSO API integration. The AI understands the intent, maps it to the right API call, handles the vendor specific config format, and executes. For a senior engineer, this saves time. For a junior, this force multiplier. And for network team that's understaffed and overwhelmed, which is all of them, this changes the game. So that's the full stack. Cisco NSO for automation, NetSims for safe lab environment, Taiga for change management, Grafana for monitoring, and AI for the interface layer. All of this is running in Docker on a single home server. The NSO eval is free from Cisco DevNet, and Taiga, Grafana, Prometheus, all open source. The only thing this is costing you is your time to set it up. Feel free to look down below in the links below. I have a thing for the documentation and how to do this step by step. If you're a network engineer and you're not learning automation, you're falling behind. And if you think automation is just writing Python scripts to SSH into boxes, you haven't even seen what's possible. I'm building more on this lab, service packages, CI/CD pipelines, maybe even full OSPF deployment videos, and AI and more. Subscribe if you want to see where this goes. I'm Eric, also known as Prime, the real Prime, the original Prime, not that Gen guy. This is network automation. Let's go.